Hey, so good afternoon, everyone, and thanks a lot for sticking around today. What an awesome day of talks it's been. It's my first time at Strange Loop, and I am just totally floored by how warm and welcoming this community is and just the level of knowledge being shared here. And I do want to take a quick moment to thank Alex and the whole Strange Loop team for organizing such an amazing, inclusive conference. And we really all owe them a big debt of gratitude for putting this together. So the title of my talk this afternoon is Towards an Open ReasonMLable Web. If you came here expecting something about machine learning, I regret to inform you that this has nothing to do with machine learning. The ML here is for meta languages, so if that's more up your alley, then welcome. The idea for this talk really comes out of two of my passions. The first is trying to make the web more inclusive to new developers. And the second is kind of this newer, exciting programming language called ReasonML. But first things first, let's be honest with one another. It is 3:30 p.m. It's after lunch. Maybe you got that second round of coffee, but I'm sort of assuming that a lot of you are starting to hit that hour where your mind is a little tired and maybe your eyes are too. Maybe you're thinking about those celebrations with people after the conference today. But I bet, you all being folks at Strange Loop, a lot of you are still totally here and focused. But kind of taking into account where we all might be at, I decided to make this talk a little bit more of a story. And it's a story about a language and the community that formed around that language. It's also a story about the future of the web and how I think Reason or something like it can give us some insight into what that future might look like. And finally, it's a story about how we create cultures around open source, especially in new programming languages where documentation might be sparse and you might need to be a bit more advanced to get involved. How can we kind of reduce that barrier in new programming languages? So before we get too deep into the story, you should know a little bit about who I am and why I'm up here. So my name is Parker. I'm a software engineer at Formidable. You can find me on Twitter and on GitHub. For those of you who don't know about Formidable, we're this pretty unique little JavaScript consultancy. Our model involves embedding with teams at companies across the world. And our goal is basically to help them level up, ship their products, and become better engineers and kinder people in the process. And it's a really, really fun job to have. We have offices in Seattle, London, Phoenix, Denver, and also a bunch of remote folks. We actually just opened up the EU to remote folks, so definitely come chat with me if you're interested. If you have heard of Formidable before, it is probably through our open source practice. Maybe you've heard of libraries like Spectacle. That is a presentation library for React, and it's actually what this presentation is written in. There's also Victory, which is a data viz library for React, allowing you to do all sorts of complex charting and visualization. We just recently launched Urkel version 1. This is a GraphQL client for React, kind of similar to Apollo client, but about half the size, and actually runs quite a bit faster. And then just this past spring, we also released Run Package, which is a metadata explorer for packages on the NPM registry. So a lot of cool things happening in Formidable open source, and I work a lot on that side of the business. I have stickers, come talk to me about it. Really, yeah, open source is a core part of our identity and definitely my identity as a developer. And kind of because of that, we have this meeting once a year where we bring everyone from every single office all to Seattle for a week to basically just talk about trends we've noticed in how the web is changing, whether it is from working on open source or the client projects that we work on. And we sort of try to ask each other questions about how we think the web is going to change. And this is kind of both on a short temporal scale, like where is it going in the next year, but also longer term in the next 5, how might the web evolve? And really, we're asking each other, how do we want to be involved in that transformation as open source developers? And how can we support our fellow software developers along that path? So let me take you back to early 2018. I had kind of just started at Formidable at this time, and that was when I was being involved in this discussion for the first time. And we were talking about the changes that we were starting to see in the open source community, in the web community, and also what our clients were asking for. And we saw two really distinct patterns emerging. The first thing was that static typing was really starting to eat the web. So teams were latching onto this idea that, go figure, a compile time type checking step could maybe eliminate bugs from web applications. Of course, this isn't a new concept in programming, but it was kind of new for the web at that time. And around 2018 was when the JavaScript type checkers like TypeScript and Flow were sort of reaching this level of maturity where they could be used in production and provide some actual benefit. The State of JS survey from earlier that year had sort of bore that out. A lot of people were excited about TypeScript in particular. Teams were adopting it at a super high rate, but also the interest in learning either TypeScript or Flow was also super high. You can see that Reason did actually make it onto this list all the way at the end. Kind of the language was in its infancy at that point. Now, as someone who had used TypeScript since version 1 at a previous company, this actually really surprised me. We had found that the type inference in TypeScript was absolutely terrible. And our team wasn't super disciplined about actually writing our types. So we were essentially getting absolutely no benefit from using TypeScript. At that time, too, the type declarations for third-party libraries were distributed via this tool called Typings that didn't work so well. Moreover, a lot of the type declarations for third-party libraries were just flat out incorrect. So it would actually break the compiler when you try to use third-party libraries. As you might expect, that makes writing JavaScript pretty darn difficult. Nowadays, we have the @types repository and definitely typed that Microsoft really maintains and does a great job of. So this has really evolved, but previously it used to be really difficult. This kind of led to the rise of what I like to call AnyScript, which was basically JavaScript code bases written in TypeScript with the illusion of static type checking, and really all of your types were just any, and you were sort of flying by the seat of your pants. The other thing that really hurt was the super slow compilation time. So, right, every time you're trying to hot reload your app, TypeScript is trying to run full type checking and then hand off to Babel or another transpiler to actually output some ES5 compliant JavaScript. And this just really ate at productivity for my team. These things have all gotten a little bit better, but as Josh's tweet kind of shows, I think community frustration around TypeScript is still pretty high. Here's an example error message in TypeScript, and as you can see, like, it's just kind of non-decipherable. Trying to figure out what's wrong when the compiler gets upset is challenging, and for that reason, a lot of JavaScript developers just sort of give up. But at the same time, as someone who has always been kind of interested in type systems, I actually did find that using a type system was fundamentally changing how I wrote code for the better. It made me a much better reader of code and a much better reviewer of code. And I was really able to see how different pieces of a code base interlinked, and I was able to actually kind of see bugs in my coworkers' code before they ever emerged. And now I don't think I'd ever go back to writing JavaScript without a type system. The second trend we were really starting to notice was that people were super interested in this story around compiling to JavaScript. JavaScript's weirdness is well known to, I think, probably a lot of people in this room. And so people were searching for these alternatives that could actually compile to JavaScript instead, so that we wouldn't have to deal with the insanity. And around this time, the WebAssembly spec was being standardized, and people were getting excited to play with it. Elm had just sort of come out and gained some traction, and a lot of people were excited about that because of static typing. The first prototypes of Svelte had come out. People were kind of toying with this idea of a pre-compile step rather than the virtual DOM in the browser. And it was all pretty interesting, but it kind of felt a little bit like people were all getting, aboard their respective hype trains. And at Formidable, when we're thinking about the technologies that we want to invest in, we're really looking for technologies where there's a good sort of open source community and open source culture that has been started there from the beginning. And for that reason, Reason was an interesting technology that kind of caught our eye. Its promise was a little bit different than everything else we had seen. So it advertised that it had this incredible type system with 100% accurate type inference. And that was really kind of the key selling point for me. I was like, wait, I can get type safety without actually writing my types. And that really blew my mind. It also talked about this lightning quick compilation process and millisecond rebuilds of large projects. So I was used to kind of waiting around for my TypeScript to compile. Maybe I would check Slack, get distracted, go back, still wasn't done, check Slack again. So the thought of having really fast rebuilds was exciting to me. And then it could also compile both to web and to native. And this was something that really interested us as well, because we were starting to write a lot of native apps in Electron at that time. And we wanted to see if we could do it without shipping the entirety of Chromium into our native apps. So that was pretty exciting. So I went home and I did some kind of like little bit of digging around Reason, and then I actually figured out that Reason is really just a syntax for this other language called OCaml. And OCaml is really pretty darn interesting. It actually allows for syntactic extensions to the language. So that actually allowed the Reason core team to basically define a new syntax that would compile into OCaml code. What was cool about that is that they could then make the syntax look like whatever they wanted to. And they decided, well, we want to make OCaml useful for JavaScript developers, so let's make Reason kind of look like JavaScript. And that's really, at the end of the day, all it is. For those of you who haven't heard of OCaml, a brief sort of TLDR on the language. So it's a functional statically typed language. Traditionally, it's been used in these academic environments, and it's really known for its performance and practicality for systems programming and type inference. So really nothing to do with the web for a long time. And it belongs to the family of meta languages that kind of began to crop up in the 70s. And it actually came out in 1996. This was a pretty old technology, and it was interesting for me to have that moment of realizing, like, oh, this is something that's kind of time-tested. What's a little bit unique about OCaml is that it actually, unlike other functional languages, it does have support for mutability and side effects, kind of escape hatches to do things that aren't traditionally sort of allowed in FP. And like I said, it allows for those syntactic extensions to the language via this feature called PPX that actually allows you to kind of rewrite your AST at compile time. It's pretty darn cool. So just to give you kind of a better sense of how Reason and OCaml and how everything fits together, we'll take a look at a super simple diagram. So this is from Dr. Axel Rauschmeyer's blog. This diagram is kind of the first thing you might encounter when exploring Reason. And so, yeah, you can really see that Reason branches off pretty early. It's basically just an alternate syntax for OCaml, and then the Reason team wrote a parser that will actually parse the Reason syntax into an OCaml AST. And then from there, you basically just hand that AST to whatever backend you want to use. So you can pass it to OCaml C and get bytecode, OCaml opt and get really high performance native code close to C or C++ speed. And then you can run it through BuckleScript, which we'll talk about in a little bit, and you can actually get JavaScript out of it. So that's kind of how it all fits together. And like I said, this was a pretty cool realization that what was new was actually really old. And that made me a little bit more excited to actually invest in Reason, because while everything else felt a little bit hypey at the time, I was like, oh, if OCaml has been engineered over decades, then I feel sort of good investing in something where maybe some of those language hurdles have kind of been figured out. I also did some digging and realized that OCaml had already been supporting the web ecosystem in ways I didn't know. So Flow, the type checker from Facebook for JavaScript, is actually written in OCaml. And actually, the very first prototypes of React were written in standard ML before they ever got into JavaScript. And it's kind of cool. The author of React is also the author of ReasonML, and he sort of intended React to be written in a language kind of like Reason. It just wasn't available at the time. Awesome. So yeah, I went home, I started playing with the language. I got really excited about how good the error handling was. So excited that I very nerdily decided to tweet about it. And it was really fun. I also joined the ReasonML Discord. And what I found there actually really surprised me. I was able to ask questions of community members. A lot of the time, they were often core contributors to the language or actually the original language authors themselves. And they would just get back to me within seconds with answers to my what felt like very naive questions. I think I had, up until that point, been used to JavaScript kind of being this entity that I had no say in influencing. And I think the Reason community did something really unique in creating this Discord, in that they allowed newcomers to the language to actually have a say in how the language evolved, what felt comfortable and uncomfortable, and they took all that feedback and really embraced kind of this open design. Yeah, like I said, this was totally novel for me, especially kind of in the world of JavaScript, TC39 and the browsers kind of handing the rules down to us. The thought that I could actually maybe try to influence how the language evolved was really super cool. What's also great about the Reason community is it's actually working to kind of bring together the JavaScript and OCaml communities to create something mutually beneficial. And I think that's pretty unique. Those communities previously didn't really talk to one another, so it's awesome to see them coming together. Now, at the same time, in embracing an open source design, I think you go through some challenges. You have to kind of decide which recommendations from new users are design elements, which things really make sense to belong in the core of the language, and what commentary is really just bike shedding. It's really just a newcomer to the language trying something and then not necessarily liking it for some sort of reason. And the boundary between those things, I think, is actually super subtle. And this leads into broader questions about who we listen to in communities, especially in new communities when we're creating programming languages, whose opinions matter, whose voices are elevated. And I think the Reason team has done an awesome job sort of considering a lot of those questions when they decide on how the language changes. At the same time, for that reason, the language has undergone 3 syntax changes, major syntax changes in its first 2.5 years. I think that's the result of sort of this kind of rapid prototyping approach that they're taking, and also the open source design to the language, where they're kind of realizing that they need to make dramatic shifts. But I really think that's starting to stabilize, and it's kind of maximizing the best of the JavaScript and OCaml communities. What was cool is while Reason was being developed, there were actually tools being developed in parallel. And the most important of these was probably BuckleScript. So BuckleScript was created by Hongbo Zhang at Bloomberg. He kind of got interested in this idea of, could I compile OCaml to JavaScript? And yes, he could. He actually wrote this full compiler. And because Reason can be parsed into an OCaml AST, it works for Reason as well. So that was a pretty amazing accomplishment. What's cool about BuckleScript as well is that it can make a lot of heavy compile time optimizations to your JavaScript. So Reason and OCaml are completely sound languages. There's really great type inference and type safety. That also means when they go to compile to JavaScript, they can actually sort of remove code that you typically would write in your JavaScript programs to avoid type errors. And instead, they can use the type system to basically determine that we don't need to include those extra branches. That means that the JavaScript produced by writing Reason is often way more performant than JavaScript you would write by hand. And that's pretty darn exciting to me. And the last thing is that that output is actually human readable. So we're sort of used to the compile to JS languages producing something that no human could actually look at and understand. And BuckleScript's output is actually very readable. You can open it up and more or less understand what's going on with it. Probably the best thing about it too is that you have this guaranteed type soundness in just milliseconds. And really what I mean by that is you are never annotating your types when you're writing a Reason program and compiling it to JavaScript. You can in some unique cases where it's necessary, but it's almost never necessary. And actually a clean build, they recently benchmarked the latest version of the BuckleScript compiler. A clean build of 1,250 files runs in about 4.2 seconds. And then a rebuild of that project with a small change to 1 or 2 files will actually complete in less than 100 milliseconds. So you're getting full type safety without writing any types, and you're compiling it on millisecond scale. So it's really pretty powerful, and I'm absolutely stoked about it. The types are also actually mathematically proven to be correct. I don't know how that works, but it's really quite fascinating. And I'll kind of show off the benefits of this type inference in just a really basic example. And we'll look at some TypeScript code and then the Reason equivalent, just to kind of show how those things differ. Cool. So let me scroll to the top here. So this is just some really basic TypeScript code. Let's say that you have just a simple identity function. It takes in some input and it returns that input. So TypeScript is actually going to infer this function as being of type any returns any. So TypeScript's type inference algorithm is based on this notion of determining a best common type. Kind of looking at a function like the identity function, it needs to determine, well, what is the range of possible values that could be passed into this? So, you could pass a string or a number, maybe an array, an object, null, undefined, kind of all of these different things, and you're going to return that same type. So TypeScript kind of infers that the best common type for all of those types is just any. This kind of comes to bite you later on. So let's say we call the ID function with a string type, just a single character. TypeScript will actually infer this ID stir variable as being of type any, even though it's pretty easy from our perspective to see, well, that's obviously going to be of type string. Same if we pass it an integer, it's still going to infer that as being of type any. And you can, of course, get around that by actually writing your type annotations. But let's see how Reason kind of differs from that process. Cool. So this is kind of the equivalent Reason code. We have our identity function. And Reason actually uses type parameters to sort of specify the type of this function. So this little apostrophe A is a type parameter. You can kind of think of it like a generic in Java or C#. And that's actually automatically inferred by the compiler. And it's basically saying, hey, whatever is passed to this function, return the same type as the input. What that means is that if we call the ID function with a data structure of type char, the compiler will correctly infer that as being of type char. If we call it with a data structure of type int, it will correctly infer that variable as having type int. So again, this is without any type annotations. It just kind of figures this out for you. And that's kind of the real big difference between TypeScript and Reason. And this is actually called the Hindley-Milner type system. It's what backs Reason, and it really focuses on this principle that for any expression, it can have at most one type. And that's what allows it to do this sort of very, very precise type inference. So I hope maybe that blew a few minds. It certainly blew my mind when I saw that for the first time. It kind of felt like Reason was getting the dynamism of JavaScript with a truly sound type system behind it. And I was like, this seems like the holy grail that I've been searching for. And so I got really excited by that, and I decided I wanted to start working on Reason in the open source community. And Reason has actually an awesome open source community because there's so much to do. So I started getting involved on GitHub, and one of the biggest kind of undertakings that exists right now is writing those like BuckleScript bindings to third-party JavaScript libraries. You can kind of think of it like writing the type declarations for third-party JavaScript libraries. That's actually what allows Reason to interop safely with JavaScript libraries natively. And really, kind of another cool thing that's been springing up that's, I think, a little bit more exciting is this notion of, can we write libraries that are useful for both the JavaScript and OCaml communities at the same time? And one of the projects that's really doing this is called Wonka. And this is a library written by my friend and colleague Phil Pluckton, who is also a member of the Styled Components core team. And he was also the lead author behind Urkel v1 at Formidable. And Wonka is pretty interesting. I worked on the tests and documentation for it. It's described as this lightweight, iterable, and observable library loosely based on the callback spec. That probably doesn't mean a whole lot to folks, but you can kind of think of it like a lighter weight RxJS. It's kind of in the broader family of reactive programming, functional reactive programming. And this idea of the callback spec is basically a way for you to pass callbacks from entities called sources, which are kind of like streams of data, and then entities called sinks, which you can think of as kind of receivers of data. So I'm not going to go too deep into how this works. What's actually more important is how it's written and distributed. So Wonka actually works both in native code bases and in web code bases, all from a single source. And the way we do this is we actually have the source code written in Reason, and because Reason can be parsed into the OCaml AST, it can also work in OCaml code bases, and then you can compile it down to high performance native code or bytecode. But Phil did something pretty clever when he started working on this library, and he wrote it in such a way that it maintains consistent behavior when run through the BuckleScript compiler, meaning it can run exactly the same way on the web. And then by distributing the JavaScript build artifacts with the npm package, he also added type definitions for TypeScript and Flow. We get to a point where we have a library that can work from a single source in 5 different code bases. And that was a pretty unique and sort of mind-bending idea when I first saw this. I think, at this point in software, we're kind of a little bit obsessed with this idea of cross-platform apps. We're really latching onto things like Electron and Flutter to kind of see, can we create apps from a single code base and run it in all of these different environments? But I think we spent less time considering the idea of cross-platform libraries. Can we, as open source authors, write libraries that can be useful for people in different communities? And really to show you how similar these APIs are when used in Reason and used in JavaScript or TypeScript or Flow, let's take a look at just some really basic Wonka code. Cool. All right, so this is some really super simple Reason code. We're going to go ahead and open the Wonka module. This basically brings all of the functions from Wonka into the local scope. Then we call Wonka's fromArray method, and this basically turns a static array into a source or a stream. And then from there, we can use Reason's pipe operator to pass it to this scan operator. You can kind of think of scan as kind of like reduce. It allows you to pass an accumulator and get a value from this source, and then you can do sort of what you want with that over time. And then just for fun, we'll pass it through a delay operator for 100 milliseconds, and then we'll subscribe to that output and just print it out. So this will actually keep running for every value in the source. So once we've hit this describe, we're actually going to go back up to the scan, run the next accumulation, delay by 100 milliseconds, subscribe one more time, scan, accumulate, delay, subscribe, so on and so forth until that original source has no more values to emit. So that's kind of what it looks like in Reason land. Over in TypeScript, we'll actually see that this looks almost identical. We go and import our dependencies. We have this kind of fancy pipe that we wrote. JavaScript doesn't yet have a native pipe operator, although I think it's coming pretty soon to the language. But we sort of wrote a wrapper around that. And then from there on out, it's basically exactly the same as your reason code. Call from array with your array. You use the scan operator to accumulate values, delay, and then subscribe to it and just print something out to the console. And keep doing that for every value in the source until it completes and you can move on with your day. So I think this is pretty awesome. Like the fact that we're writing a library from a single source that's working this consistently across different code bases and environments is awesome. And I definitely encourage you all to check out the Wonka library. Another really cool project that I've contributed to a little bit is called Reprocessing. So this was written by Avery Morin and Ben Sansusi, and it's a popular port of the processing language into Reason. It allows you to create these really complex graphics and visualizations. And people have made some awesome things with it. There's like Perl and noise visualizations. There's small physics engines for games. Someone actually wrote a cross compiler for this, so you can actually compile it to iOS and to Android, which is pretty darn awesome. It bills itself as a library inspired by processing that allows you to create these cool visualizations that can run on the web using WebGL and natively using OpenGL. And actually, the way that they achieve this is they have an underlying library called ReasonGL, where they wrote the BuckleScript bindings to the WebGL API, and then they used OCaml and actually used OCaml's interop with C to write bindings to the OpenGL API. And then basically all you have to do as a user of the library is just tell reprocessing, I want to use the JavaScript backend or I want to use the native backend. It's kind of a one switch flip to get the exact same visualization running on web and on native. And I think that's super clever. Here's just like a quick little demo of what this looks like. So I made kind of the classic bouncing ball sketch in reprocessing. This is kind of maybe the first thing you do if you're working on a processing sketch. And kind of in that left terminal, I ran this yarn start command, and that basically is just telling reprocessing, hey, go and use the native OCaml compiler to compile it to OpenGL. And then on the right-hand terminal, I'm literally just serving that code over localhost, and that's just the compiled JavaScript, that BuckleScript output. So it's the exact same source code, and you basically just switch out the backend that you use to compile it, and you have it running exactly the same and predictably on both web and native. That's, I think, just absolutely incredible that we can achieve that. Awesome. So at this point in the talk, you're probably wondering, like, why aren't we rewriting the web, or at minimum, our native apps in Reason? Or maybe you're like, I'm not at all interested in this language, but humor me for a second and go along with me on this question. And I think there are kind of a couple ways to approach this. I think we're still really in the early adopter stage of Reason. I think we're kind of feeling this a little bit with other languages too right now. We know that there are sort of problems with JavaScript that we'd like to fix, and we're kind of figuring out, like, what is the solution to that? And I think there have been a ton of good developments in that space, and we're all kind of trying them out right now. I think a lot of us here are probably early adopters type folks. We like to try new things, but you know, I honestly don't think Reason is right for every single team, especially if your core set of developers are JavaScript devs who can work with TypeScript pretty well. Like, that might get you pretty far. Another thing is that a language is really, I think, only as good as the community around it, and secondarily, only as good as its documentation. Part of what makes JavaScript so successful is the community is really big and the documentation is really good. You can find a lot of resources on getting started with JavaScript, and there are a lot of ways to just sort of get up and running with it. I think Reason is really lacking in this sphere. There is a broader effort underway to get the documentation to a better place for newcomers, but I have found myself digging through some pretty esoteric OCaml documentation, and that's a pretty difficult thing to heap onto new developers. And finally, I think Reason is really trying to bridge this divide. And I don't think this is really a strong divide, but it's trying to bring together these two communities that have basically never talked to one another JavaScript and OCaml have been around for roughly the same amount of time, and they haven't really crossed paths until now. So, I think it's pretty difficult to figure out how to reconcile the values of those two communities and try to come up with something that's going to work really well for both of them. And I think it's really natural for that process to take some time. So if there's one thing I want you to take away from this talk today, it's really not that I think Reason is the be-all, end-all of how the web is going to change. Rather, I think the experiment of Reason kind of sheds some light on what we should be thinking about and what we should value when considering this question of what direction is the web going. And I think that can involve kind of taking technical inspiration from other languages. Reason has all the good things: immutability by default, static typing and type inference, these heavy compiler optimizations. It's really, really similar to Rust and kind of has all of that good stuff. But I think what feels even more important is really pushing ourselves to think about how can we start seeing our programming communities as these living, breathing organisms that are subject to social and political difference, and how can we start kind of bridging those divides and coming together to create something in the open together that is really inclusive and really powerful for everyone. Yeah, that's all I have. If you want to chat with me or have questions, I'm definitely happy to answer those. And you can also hit me up on Twitter or on the conference Slack. And again, thank you so much for your time. Cool. Does anyone have any questions? I know that was a lot of information. Yeah. So the question is, can you generate WebAssembly as well? And this is, I think, maybe the most asked question in the Reason community right now. And the answer is we're very, very close. A few people are working on kind of the OCaml to WebAssembly story. And basically the last thing that they need to implement is garbage collection. And I think there's a lot of kind of sticking points with that are a bit over my head. But we're basically at the point where once we get the garbage collector in place, the OCaml to WebAssembly story will be totally done. And again, because Reason is basically just a dialect of OCaml, it will totally work with WebAssembly at that point as well. So I think in the next year, the Reason to WebAssembly story is going to be ready for production. Yeah.
You mentioned wanting native Electron. Is that something you accomplished?
Yeah, so it is something that I accomplished personally on just side projects. We're sort of considering investing in it more heavily at Formidable. There is a new UI framework that came out for Reason called Revery, and it kind of provides a React-like API for UI development, but it compiles all down to native code. Even it has sort of a very similar hooks API that React has. So it feels a lot like writing React code, but it compiles to super fast native executables with basically instant startup. And I've actually performance tested it against Electron apps with super high intensity data visualization, and it performs significantly better than Electron. And it really is just not having all of Chromium running in your application. Yeah.
One of the challenges I found is in TypeScript is you've got these types which are great, but then you start interacting with a bunch of block JSON data. There's types you think you know, but you have to actually do architecture by hand to make sure. Is there anything in the ReasonML process that helps you deal with interfacing with the real world of the untyped things?
Yeah, there is. There's actually been a lot of work done in that sphere. So BuckleScript provides some kind of high-level APIs for serializing and deserializing your JSON. And then recently, Jared Forsyth, who's kind of one of the biggest, most active members of the Reason community, created this project called Milk that will actually do automatic serialization and deserialization of your JSON for you. And you basically just give it access to, you basically just hit a backend endpoint. And then it will actually store kind of a local configuration file for you that will do all of the type inference and serialization and deserialization for you. That's also the case with GraphQL, where there's kind of this process set up right now in a lot of the GraphQL client libraries, one of which I maintain, so I'd be happy to chat about. But you basically just point it at your schema. It'll run an introspection query on your schema, and then it will actually type check all of your queries on the client side. So you can basically never send malformed queries to your GraphQL API, and you get full type checking at compile time. So it's pretty cool stuff. And yeah, I think definitely that story is much more fleshed out in Reason than in the TypeScript world. Yeah. I have not tried PureScript. Yeah, it's something I've sort of thought about. I think for me, the attraction to Reason kind of happened because the community was just so welcoming immediately. I'm sure that's probably the same for the PureScript community, but I just haven't really had time to investigate it. But I'm certainly interested in anything with really strong static typing and type inference. Awesome. Well, I would love to talk to anyone more about Reason after this. And again, thank you so much for coming. It really means a lot.